Okay. So, oops. Go away. Okay, anyway. So you should see 3 numbers at the top, and those 3 numbers correspond to the 3 different elements of your exam. Okay, so you'll see those numbers circled on the bottom of the pages corresponding to that. So like I said, you will actually see your percent. I keep thinking I'm on a different app. You actually will see a percent. The percent you see was the number you got right divided by 55 instead of 58. Okay, so the first question was a question about, actually, remember in your lecture, remember in lecture we had those kind of strips of the Milky Way galaxy, and we actually had the Milky Way galaxy as it would appear at different wavelengths. And the reason for that is so we can see actually into the heart of our galaxy. So that's what I was after. And that was actually in that same chapter on the Milky Way at the end when we talked about how do we see Sagittarius A star. Actually, we see Sagittarius A star by looking at using different wavelengths. So A was the best answer for that. Question 2, galaxies we know collided a lot more frequently early on in our universe, and the best answer there is that they were closer together, B. Question 3, what kind of a star is most likely to go supernova type 1A? And of course, you're looking for a companion situation. So the best answer there is E, that actually it's a white dwarf that has a red giant and it's being dumped on. Question 4, what kinds of objects are in the halo of all galaxies, especially our galaxy? Those would be those older clusters of stars, C, globular clusters. Question 5, how do we know how galaxies evolved since the Big Bang? And the best answer is that we compare their far-away baby pictures with their closer up older pictures. So E was the best answer there. Question 6, what feature of the black hole separates it from the rest of the universe? The best answer there is D, the event horizon. Question 7, actually, in order for something that is within the event horizon to escape the effects of a black hole, it needs to be going, the best answer there is C, faster than the speed of light. Question 8, and actually this wasn't one that was specifically on your review sheet, but we've talked a lot about, okay, kind of the compactness of a white dwarf and a neutron star and a black hole. So what I was after here is that actually if you were to be able to recover a teaspoonful of black hole, it would weigh a lot more, okay, than anything else listed there. Question 9, what's the upper limit to the mass of a white dwarf? That would be the Chandrasekhar limit, D, 1.4 solar masses. 10, what is the general relationship between the nuclear bulge and the spiral arms for either a spiral or barred spiral? And we said in lecture A that the more tightly wound the spiral arms, then the thicker the nuclear bulge. Question 11, compared to the stars that are in the disk of our galaxy, most stars in the halo are actually old, they're relatively red, okay, they're like kind of low mass, and they're dim, they're M-type stars in the globular clusters, and they are kind of more like population 2, fewer heavy metals. So E was the best answer there for 11. Question 12, Hubble actually provided the missing piece of distance to the Andromeda Nebula or the Andromeda Galaxy to solve an important concept in kind of how our universe is set up in 1920s. So B is the best answer there. Question 13, the galactic center lies in the direction of the constellation Sagittarius A. That's why they call it Sagittarius A. I love it when things make sense. Question 14, if you observe a galaxy that's 100 million light years away, the best answer there is D, that you will see that light as it was 100 million years ago, and it will be redshifted. D is the best answer for 14. Question 15, what evidence do we have that there's a black hole in the center of our galaxy? And since our galaxy center is not really active, the best answer there actually is C, that we can observe the motions of stars, and based upon their dance with Sagittarius A star, we can get a fix on the mass of Sagittarius A star. We know its volume, so its density must be that it is a black hole. So C is the best answer. Question 16, which of these can reoccur? And actually B, C, and D cannot reoccur, but A, nova events can reoccur if it so chooses. Question 17, a white dwarf is the best answer there is E. It's actually a retired or dead star, and it is supported by, and I guess this is one I didn't necessarily put on this review sheet, but it's supported by electrons bumping up with electrons. It's normal matter. It hasn't collapsed into neutron soup, okay? So best answer is E. Question 18, where does most of the star formation in our galaxy occur? The best answer there is in the spiral arms or the disk. Question 19, if you were to photograph many galaxies and assuming that those photos were all taken at the same time, which galaxy would look the youngest? And A, that's the one that's farthest away. Question 20, what is the diameter of the Milky Way galaxy? It's about 100,000 light years side to side. A couple more multiple choice questions. 21, based upon Hubble's observation of recessional motion of galaxies, basically, we can use his scatter plot to gauge the universe to be about somewhere between 12 and 15 billion years old. Question 22, the only statement that's correct is E. If we're comparing white dwarfs that have a solar mass of 1.2 and a solar mass of 1, actually E, the 1.21 will have a smaller radius. So worth 2 points apiece was this section on vocabulary. Now, so it's possible that you could get 1 out of 2 points. So actually, question 23 is such a situation. I was really after the general term. I can't remember. I may have gone full 2 out of 2. But I was really after the generic term standard candle is an object that we know its luminosity, and we can use it to compare it to its brightness to get to distance. Gravitational redshift was 24. Where you're trying to, an object's trying to escape the vicinity of a dense object, and that dense object's making a dent in the fabric of space and time, and it has to crawl out and lose some energy, and becomes reddened in doing so. Question 25, Hubble's law, and in some case, if you put recessional, I don't know. Some cases I accepted half credit for this, but I was really after Hubble's scatter plotter, his law that that actually links how far away a galaxy is to its recessional velocity. Question 26, a repeating signal from this object indicates the presence of a neutron star. That was pulsar. Sagittarius A star was 27, the thing in the center of our galaxy that is we now know is a supermassive black hole. Question 28, I was after halo, is where the globular clusters hang out, and it's the region outside the disk. 29, protogalactic cloud is a region that actually is going to ultimately form a galaxy of stars, and it's generally rich in hydrogen and helium. Question 30, I was after quasars, as those energetic events that are thought to be associated with a feeding or active supermassive black hole in the center of a galaxy. The event horizon, of course, is the thing that separates the black hole from the rest of the universe, what we saw a minute ago, and actually that marks the region beyond which, if you go towards the black hole, you cannot escape even going the speed of light. So this last page, these were all worth 3 points apiece. So some of them were harder than others. So 32, you could have simply said that the galaxy is feeding, and I would have given it to you. But when we say a galaxy is active, remember, think quasars, and actually remember that energy, even from a quasar, can't escape a black hole, supermassive black hole, if it's on the other side of the event horizon. So these things are all happening outside the event horizon. Question 33, a couple of frames of reference. According to Einstein, if you're standing still and somebody is in a frame of reference that's moving very fast, the faster it's moving, closer pushing the speed of light, the more you're going to see these effects. But with regard to that person's length, he'll think it's fine, but actually it would shorten relative to you observing it. Time would tick off more slowly, unfold, I saw that a lot, more slowly according to your stationary frame of reference, and that person or those objects in that frame of reference would become more and more massive. 34, this was a homework question. How do you compare the motion of the disk stars versus the halo stars? And disk stars are more orderly, halo stars are more random. And then question 35, I would have either taken spirals, barred spirals, and ellipticals as the 3 main types of galaxies. But if instead of barred spirals you put irregulars, I was good with that. But you also had to describe them a little bit. Some cases it's hard to kind of differentiate between spirals and barred spirals, but the difference is barred spirals actually have a bar of stars that kind of go across its nuclear bolt. Question 36, describe, and you guys could use a picture. This online students had a hard time doing that. But what sort of situation is it when you have a nova event occur? So of course I had a binary system with a swollen red giant and a white dwarf. An accretion disk forms around the white dwarf, and an explosion that can reoccur happens on in the accretion disk around the white dwarf. So 36, actually, some of you didn't get full credit, and so I kind of tried to say why that would have been. Question 37, the last question, kind of described the difference between population 1, population 2 stars. And this is one of those examples of things I think is kind of a little bit backwards, but of course population 2 stars are our grandparents, population 1 stars are our newer stars. Population 2 stars then would be metal poor, population 1 stars are generally located kind of only in the disk, and they would be metal rich because they're made from previous stars who have lived their lives and given it back. Okay.